Dear students, today we can revise the topic spring force and friction. At first, we can discuss the theory parts with the problematic situations. Here, the springs are helical and in spiral in structure and are stretchable and compressible. The springs are assumed to be massless. The elastic force in a spring is assumed to be same everywhere. The elastic force, we can write that F is equal to minus K into X are same everywhere. And we are taking that stretch or compression is always taken to be positive. The restoring force developed due to elasticity of spring is equal in magnitude but opposite to that of the applied force. Look the figures. For small stretch or compression, the springs obey the Hooke's law. So we can write as F is equal to minus K into X. Here, the force extension graph, if you just take the slope, then you get the force constant or the spring constant. Keep in mind, the force constant or spring constant is inversely proportional to the length, and we can draw the K versus L graph like this one. We can move to the next concept. See, the springs in parallel, there keep in mind the individual force constants are added together. The springs in series, the 1 by K effective takes the value as 1 by K1 plus 1 by K2. Here a good question is waiting. Find the extension in both the springs. Look the figure. Both the spring got the same force constant. It is 1 kilogram M1, M2 is 2 kilogram. So look the free body diagram. For M2 at first, here its weight 2 into 10 is acting vertically downward. The T2 tension is acting vertically upward. And for this one, vertically downward, T2, it's 1 into 10 weight downward and T1 is in the upward direction. So under equilibrium, we can write the relations like that. And we needed to find the extension on different springs. For the first spring, the tension can be written as K into X1. And similarly for the second one as K into X2. Another good concept, by going through these type of questions, we can solve any problems regarding the spring like that. A good concepts are waiting. Two blocks are connected by a spring of natural length 2m. The force constant of the spring is 200 Newton per meter. Find the spring force in following situations. Look the figure. A is kept at rest and B is displaced by 1 meter in right direction, left direction. The third question, A is displaced by 0.75 meter in right, B 0.25 meter in left. So the first condition, the extension in spring is 1 meter. So F is equal to K into X, 200 into 1 equal to 200 Newton. But in the second case also, the same extension, so the same force in both the directions. So we get the same value. But in the third case, both the displacements A and B, here one is along right, another is along left. That means both together compress the spring. So the total compression becomes 0.75 plus 0.25 equal to 1 meter. So the force acting on the spring is equal to K into X, that is equal to 200 Newton. A good asked question is waiting. Very good question. If x1, x2, x3 be the extensions in the spring as shown in cases, write down the mathematical relations between x1, x2 and x3. Look the figures. We are waiting with x. Very good questions. Look the figure. Just to compare the masses hanging on different strings. Here the three springs are there. At the first pulley system are hanging with equal weight, but in the other two cases it is different. So in this case we can write the expression that T is equal to K into x1 is nothing but its weight 2 into G. But for this case the situation is different. So there is an acceleration. So the T is K into x2 equal to, and if you just consider this arm, that 3G minus, there should be a movement. So that can be find out is equal to 3 into what is the acceleration on the body. That can be simply find out 3G minus 2G by 3 plus 2. So you get the answer. And similarly we can find for this one. But K is the same for 3. So you can write the expression for K and we get the solution like this. Look at the very important concept. The spring balance. If both the leads are tensioned with the T same, then the reading is T by G. Keep in mind, the spring balance measures always in kilogram weight, and hence the tension by G. That means in order to measure the mass, we can use the spring balance. The same concept is here also. And here the spring balance, but on the two ends with the same weight. So here it is weighed by only one weight, 50 kilogram, and the other end behaves as an infinite rigid boundary. So the reading are same. Look the next concept. Very good, very good. Two spring balances, only one weight, but both of them read the same. But here only one, the two masses are there, 10, 10, but it will give a 2T tension here, and hence the reading becomes 20 kilogram weight. But here this is 20 kilogram, but it is divided into two, therefore 10 kilogram weight. Then what is the case here? You know, for a pulley system, the last video, you know, what is the tension here? So in this case it becomes 2T double T by G, that is the reading. A good question. Look here, an accelerated frame, upward, downward. Look here, the G is replaced by G plus A by G, G minus A by G. So keep in mind the very important concept. Look the figure, a good question. Given the reading of this one, S1 is 90 and S2 is 30. If the masses are stationary with respect to the lift, then determine the mass of the block M. So with respect to this one, we can write 90 reading is M into G plus A by G plus the bottom as 30. So you get the answer as 30 kilogram. And we are waiting with a very important type. Very, very important, especially as a J main is considered. The dependent motion of connected bodies. We can solve such problems by method of constraint equation and method of virtual work. We can go with the two examples. One, look the figure. Find the acceleration relation of two blocks 1 and 2. The first method through the constraint equation. Look the figure. Here this distance is x1 and this distance as x2. So the total length is a constant. we can write x1 plus x2 plus x3 is equal to constant. You just differentiate one time. You get it in terms of velocity. Again we can differentiate. You get the acceleration. Here the a1 is coming downward. We can take it as negative. And a2 in the upward direction. So you get the answer. So that is the method of constraint equation. Method of virtual work, the very important concept. Look below, the sum of the scalar product of forces applied by the connecting links of constant length and displacement of corresponding contact points equal to 0. Sigma Fi dot dx equal to 0. Fi dot Vi equal to 0. Fi dot Ai equal to 0. Look the figure here. Here only the movement links are this block and this block. And here the tension is in the upward direction. And the A2 is along the same direction. So the tension and acceleration makes an angle of 0. Cos 0 become 1. So 2t into A2. But here the tension is upward and the acceleration downward makes an angle of 180 minus ta1 equal to 0. You get the answer. So that is the simplest method, the method of virtual work. We are with the same type of question again, a good aspect. We can wait such questions for JEE Main and JEE Advanced. In some cases only for NEET exams. If block A is moving with uniform velocity V, then find out the velocity of the block B. Look the figure. By using the constraint relation, you just write for the string 1. The string 1 is this one and the string 2 is this one. For the string 1, this is labeled as XA and this ring, so that is D minus XP. So 2XA plus D minus XP equal to L1. For the second string, we can write so and so. You can just differentiate one term and you get the answer. But again another concept, by using the method of virtual work, the movable blocks are A and B. And look here, in the direction of tension. So 4T into VA minus T into VB. Look the figure, how it become 4T and T. So this string is taken as T. Then here it must be 2T. But it is connected to another one. So that must be 4T. So you get the answer. And these two examples will give a good idea about that two methods. The friction, you know the simple concept about the static friction, limiting friction and the kinetic friction. So keep in mind what do you mean by the angle of friction. Everything are so comfort points, but we can move with the very difficult situation. So you know what do you mean by angle of repose. For an inclined plane especially, the frictional force is what? So there we can derive it to be tan alpha is equal to the static friction. While solving problems, you must go through the 5 steps. Is it rough surface or smooth? That is the finding should be done by you. And the second one, is it friction force is 0 or not equal to 0? And the nature of friction. And keep in mind, is it the body is at rest or the limiting rest? So just going to motion or not? If it is normal rest, applied force is the force acting. And if it is limiting, and we can say the static friction. If the kinetic, we can write mu k into n. And you just analyze the direction of friction. Then draw free body diagram. So these 5 steps should be there while solving problems. See the question. If body pulled up along a rough inclined plane surface, so you have to do the work against the frictional force and the weight component, and hence we can write it as like that. a body pulled down along the rough inclined plane. So here the situation becomes mu mg cos theta minus mg sin theta. A good aspect, minimum force required to pull a block. And see that F can be split into two components. So here the normal reaction plus its sine component is equal to mg, and F cos theta, that is equal to mu times of n, and n is mg minus f sin theta. So the the force F is equal to mu mg by cos theta plus mu sin theta. Look carefully the steps. See, find the maximum value of F so that both move together. There is no relative motion between A and B. See, both the bodies are moved together. So the acceleration of the system is simple. Look the free body diagram of a small m. The weight mg is acting, the reaction, the frictional force acting on it. So that is mu times of n1. So mu mg is equal to, the force acting m into acceleration. So we can find the F max. What is the maximum value of F so that both move together, but here the force is acting on the small m mass? Draw the free body diagram and can be written as acceleration of the system is equal to F by small m by capital M equal to mu mg by capital M. So you can solve it to be like that. 2 and 3 block problems in friction. You have to move with the 4 steps. The first step, decide the direction of frictional forces. The block on which a net force is applied to pull or push, friction on both of its surfaces direction opposite to the force. Friction between two surfaces in contact makes action-reaction pair. These forces act in opposite direction with equal magnitude. Keep in mind. And the second step, decide range of friction forces between each pair of surfaces in contact. If coefficients of static and kinetic frictions are different, you have to take this relation. But if coefficient of static and kinetic friction are same, decide the maximum possible acceleration each of those blocks which accelerate only due to friction. Then the sequence of slipping. If friction is 0, anywhere below the block on which force is applied, slipping first starts there. Out of the blocks which has least maximum possible acceleration, start slipping next. It starts slipping with respect to that block which has next higher maximum possible acceleration. Read carefully the 4 important steps. Then you can easily solve the problems. The special cases, both the surfaces are rough. Here mu1, mu2. The masses m and m2. And here the forces is acting on the bottom mass. Look the free body diagram. So with respect to this figure, so here we can write that F minus F1 plus F2 equal to M1 into A. And you can use for the free body diagram for M2 as this one. Then you can write the relation for F1 and F2. And you can substitute these values on this relation. Then you get the answer. So the free body diagrams are very, very important. To sense it, we can use these laws. And again, the similar concept, but here the both surfaces are got friction. but the total force F is acting on the top one. Again, draw the free body diagrams. Look the figure carefully. Then write for the separate masses the mathematical relations. Then you get the acceleration and the force acting on it. We are with a good question. Block A and B of masses 5 and 10 kg are placed as shown in figure. If block A is pulled with 50 Newton, find out acceleration of A and B. If coefficient of friction between A and B is 0.5 and between B and ground is 0.4. Look the figure and look the free body diagram. Write the mathematical expressions. Then you get so easily the answer. Next question. Block B is pulled horizontally by a force F which increases gradually. Find the maximum friction between each pair of surfaces. Decide the sequence of sliding between various surfaces in contact. Also calculate the minimum value of F for that. A good question. You just look the figure. A good aspect. See, A, B, C blocks with the friction between the surfaces 0.1, 0.2 and 0.1. Got the masses? That capital F is acting in this way. Look the free body diagrams. So you can find F1 max, 2 max and 3 max. Then block A and C moves due to the frictional forces. So we can find their accelerations so easy. As AC max is greater than A, so slipping between B and C starts before slipping between A and B. And also as F2 max is greater than F3 max, so slipping starts first between ground and C. So please go through every problems carefully, then you get an idea how to solve the problems so neatly and clearly. So wait for Newton's laws of motion for the NEET examination. You can wait 2 to 3 questions. For KEAM entrance, you can wait 4+1 question. For JEE Main, 2 questions. Take care. God bless you. Thank you.